In Chapter 13, we want to learn other ways of calculating dosage. We have talked only about one way, and that is taking the desired, what the doctor orders, divided by what we have times the quantity. But another way that we could use to calculate dosage is by using the ratio and proportion method. Some of you may like this better. It doesn't mean that you can't still use what we have learned. You still can, but this is just another way. And so I think it's good to see other ways of solving, because when you are working with different measures, one way tends to be easier to deal with sometimes than others. Well, still, the first thing that we have to do is to convert. We have to have all the units in the same system. So if we're dealing with weight, it has to all be in the metric system. If we're dealing with the amount of medicine, like milliliters, if it's an injection, a tablet, all of it has to be in the metric. And so we do our conversions. Then step 2, we still can a lot of times estimate very close to the amount of medicine that you would give. Would you give 2 tablets? Would you give 1.5 tablets of the medicine? Well, if you use the ratio and proportion method, this is what you do. You take what you have on hand, the dosage on hand, divided by the amount on hand. And that will equal the dosage desired divided by the amount desired. So let's look at an example. Let's say the doctor orders some clindamycin, 0.6 grams IV every 12 hours. What we have is 300 milligrams of clindamycin per 2 milliliters. Well, we have a mismatch. We have grams and we have milligrams. So remember, our rule is that we convert to the smaller units. So I'm going to change grams to milligrams. So I remember that 1 gram is 1,000 milligrams. 0.6 grams is what the doctor ordered. So how many milligrams is that? So I have grams over milligrams, grams over milligrams. Those have to be set up that way. So now when I do cross products, I have X equals 1,000 times 0.6. So 0.6 times 1,000 simply moves the decimal 3 places to the right to get 600. So 0.6 grams is 600 milligrams. So I've done the conversion. I now have all the units changed to milligrams. And I think, what was the dosage? The doctor needed 600 milligrams, and we've got 300. So I need to give double this amount. So double 300 would be 600. So that's what you think. And if 300 is 2 milliliters, doubling that would make it 4 milliliters. Now we go back and do the math to make sure that what we thought to be true would be true. So the dosage on hand is 300 milligrams, and the amount you give is 2 milliliters. So 300 milligrams for every 2 milliliters. What we desire, what the doctor ordered, was 600 milligrams. So how much medicine would you give? So we do cross products. 300x equals 2 times 600. Divide by 300, and you give 4 milliliters intravenously every 12 hours. And that's what we kind of thought would happen as we were thinking about that ahead of time. So convert, think, then calculate. The dosage on hand per the amount to give. The dosage the doctor orders, and you're wondering how much that would be. So those are how those will always be set up. So if you like the ratio and proportion method, that is a good way of calculating. Another method that you could use is called the dimensional analysis. So first you determine the units you want to administer. And that would be determined by the physician, whether you're giving tablets or whether you're giving milliliters. So is the medicine going to be given orally, or is the medicine going to be given by injection? Now you can give milliliters orally. You can have an oral liquid medicine. But a lot of times we think of milliliters as being an injection. Of course, a tablet would not ever be. It would always be given by mouth. So let's say that the doctor orders Lanaxin digoxin, alias digoxin, 125 thousandths milligrams orally once daily. A Lanoxin 2500ths tablet is provided by the pharmacy. They didn't give us the units here, so if we are trying to think of whether we're going to have to convert to the same unit or not, would be a little difficult. First, when using dimensional analysis, you must determine the unit you wish to administer. So tablets and how many tablets. Then we think. So let's go back and look. So I'm going to assume that this is 25 milligrams. The pharmacy has 25 milligrams. The doctor wants 125 thousandths milligrams. Well, if I think about that, this is half of 25 hundredths. So I'm going to be giving him a half of a tablet. So if this tablet is a scored tablet, then he can simply cut it in half. Now that's what I would be thinking as a reasonable amount of drug to give. Then you calculate by setting up the right side of the equation to include all the necessary conversions and equivalents. So your variable x will be by itself, x equals, and then you will have all the other conversions and equivalents on the right. And you have to be careful that everything is going to cancel out except what you want to end up with, like tablets.